All right, welcome to Thursday's fun day of review coordinate geometry proofs. Going to be a little bit longer than the other ones. We have 3 proofs to do today, so we'll get started and try to get through them as soon as quick as possible here. So, taking a look at the first one, we want to show that quadrilateral ABCD is a rhombus and then is a square. So remember, for rhombus, right? The easiest way to do it is to get 4 congruent sides. So we're going to need the distance formula here. Okay, so we'll do with 2 distances, and then we'll do 2 with Pythagorean theorem. So the distance of AB, starting first, square root. Okay, starting with B, we're going to do x2, which is -2. So remember the distance formula, if you need it, square root x2 minus x1 squared plus y2 minus y1, and then squared. Okay, the slope formula, once again, is y2 minus y1 over x2 minus x1, and then the midpoint formula is the average, so it's the x2 plus x1 over 2, and then y2 plus y1 over 2. All right, so we're going with x2, which is -2, minus x1 from A, which is -6. That's going to turn into a plus squared, and then plus, and then we're doing the y's. So it should be 3 minus -2 squared. So once again, that's going to turn into a positive. So the distance of AB becomes -2 plus 6 is 4 squared, plus 3 plus 2 is 5 squared, and then this is 25 plus 16. And so that is going to be 3541. So we need to get that for all the other ones. All right, so we're going to do the same thing for BC. So the distance of BC, so square root, okay? So we're going to go x2, which is coming from C, so 3 minus -2 squared, so that's going to be the plus squared, trying to make it a decent 2, failing. And then the y's, so from C, -1 minus 3 squared. So this is going to turn into, and here we have 3 plus 2 is 5 squared plus -4 squared, which is 16 plus 25. So that once again is the square root of 21. And then we can do our Pythagorean theorem if you'd like. So you get from D to C, we're going to go over 1, 2, 3, 4, 4. So plus 4. And then up 1, 2, 3, 4, 5. And then get from A to D, we're going to go down 1, 2, 3, 4. That's -4. 1, 2, 3, 4, 5. So we're going to have to do 2 of these because we have different numbers. We're going to do them for both. All right, so the distance of DC is going to be 4 squared plus 5 squared equals C squared. This is 41. And then the square root of 41 is our answer. All right, and then the last one is going to be the distance of AD, which once again we're using the Pythagorean theorem here. So A squared plus B squared equals C squared. Here we have -4 squared plus 5 squared. Once again, 41. And then the square root of 41. All right, so now we can say that it's a rhombus. So we got the work. There we go. I'll say A, B, C, D. Rhombus, since all sides are equal. And we know that all sides are equal since the distances are congruent. And actually, we're going to switch this. We're going to put congruent here instead of equals. Okay. And we're going to add that part. Okay. Now we got to do a square. So remember, to make a rhombus a square, we just need one right angle. So we're going to do the slope. We already have AD and CD kind of laid out for us. So we'll do the slope formula for one of them, and we'll do rise over run for the other one. So let's do for AD. AD, slope. Excuse me. Okay, so for, where are we at here? So for AD, y2 is going to be -6 minus y1, which is -2, over d, which is -1. That's the x, and then minus -6 for this one. So we got 2 plus of positives going on here. -6 minus 2 is -4. -1 plus 6 is 5. So the slope of AD is -4 over 5. The slope of DC, we're going to go ahead and put down rise over run because we're going to use the graph here. We've already marked it on our graph. So we can just put down that it's +5 for the rise and +4 for the run. And so you can see that AD is perpendicular to DC because the slopes are opposite or negative reciprocals. So that's going to form ROCALS for that one. That is going to form a right angle if it's negative reciprocal. And so now we can say that ABCD is a square, since it is a rhombus with a right angle. All right. And there we go. Let's edit this down a little bit. All right. Second question, we want to show that this thing's a parallelogram and then a rectangle. All right. So since we want to get it to be a rectangle, we're just going to strictly use the slopes. And we're actually going to use all 4 slopes. Because remember, we can do 4 slopes for the parallelogram, and we're going to need them to be a rectangle. So I would say if we were going to have an exam at the end of the year, we're not going to this year, all right? I would say learn one of the ways and stick to it. So when you see a parallelogram, you're always going to do this. Okay, I like using slope formula. It's pretty easy. I think it's a little bit less writing as well, but so slope of AD. So starting with AB. Starting with B, the y coordinate is 6 minus 3 for A, and then 11 minus 2 for the x's. 6 minus 3 is not 3, 11 minus 2 is 9, and so I get 1/3. So I already know that slope of DC should be, okay, because it's going to be an opposite reciprocal. So for DC, starting with C, it's 9 for the y minus 6 for the x, and then 10 minus 11. So 9 minus 6 is 3, 10 minus 11 is -1, and you can see we get opposite reciprocals. Okay, the next slope should be CD. This should be the same as AB, so we should get 1/3 for this one. All right, and we're going to do the same thing here. Hold on a minute. We did AB, and then we did CD. These should be the same unless I'm doing something wrong. 6 minus 3, 6 minus 3, 11 minus 2. Ah, I see it. See, I caught it. I saw CD, which is this line right here. This line should be parallel to that line right below it. And for some reason, I'm getting opposite reciprocals, which I shouldn't. I messed up this part right up here. Okay, so this should be, I was doing BC, not CD, but I labeled CD. Let's stick with it. So actually, let's change this to BC. Sorry for the craziness here. BC should be 9 minus 6, right? 9 minus 6, 10 minus 11. And there we go. All right, so that's BC instead of CD. Now we're doing CD. So this should be 6 minus 9, right, over 1 minus 10. So this is negative 3 over negative 9, which comes out to be 1/3. Perfect. And then the slope of AD, which is 6 minus 3, starting with D, and then 1 minus 2. And so here we go. We're going to get 6 minus 3, which is 3. 1 minus 2 is negative 1. And there we have it. So we're going to go ahead and say that this is a parallelogram. Opposite sides are equal, and we know that slopes are the same. So ABCD is a parallelogram. Since opposite sides are parallel, the slopes are equal. And then we can continue on now and say ABCD is a rectangle. Since it is a parallelogram with right angles, slopes are negative reciprocals. All right. Now there might be people that might want to put down like this is parallel, this is parallel, this is parallel. Like these two are parallel, these two are parallel, and then these guys are perpendicular. But as long as you're doing your statement and you're justifying it with the here's the shape, here's the property, and this is what I did to show it, then that should be fine. All right, going to the next one. We got ourselves a trapezoid. So we're going to do two things. We're going to show it's a trapezoid, and then it's isosceles. All right, so remember trapezoids, we need to get the two sides parallel. We're also going to show the other two sides are not. So once again, we're going to do our 4 slopes. All right, so the slope of TR, that's Kate.
Yeah, but there's a new soap file.
And we're going to go same thing for y's first. So 5 minus 0 over 0 minus 0. So this turns out to be 5 over 0. And actually, this is undefined. You can't divide by 0, people. Okay? Then we're going to do the next one, which is the slope of RA. So starting with A, y, 8 minus 5. X's is 9 minus 0. So that's 3 over 9, which is 1/3. Okay, we have the slope of AP. Okay, which is from P, 4 minus A, which is 8, over 12 minus 9. And here we get negative 4 over 3, so that doesn't match that. And then the last one is the slope of TP. So we know this should be the same. It should be 1/3. So here we go. We're going to go 4 minus 0 for the y's, 12 minus 0 for the x's. And this turns into 4 over 12, which is indeed 1/3. So we know that RA is parallel to TP. TP, not TR, people. Okay, slopes are equal. And then the last one we got is, you can see it's a parallelogram now. So TRAP is a parallelogram. Since it is one pair of sides parallel, slopes are equal. All right, we could also say here that TR is not parallel to AP. Slopes are, and then we got not equal. All right, and I don't have the not parallel sign, so we got to do it by hand here, but slash. All right, next thing we need to do is we have to do that it's an isosceles trapezoid. So I'm just going to write down these 0, 0, 0. Whoa. Feel free to skip past this part if you really want to, but it'll take just a second. It's just so we have it to do work. All right. Proof it's isosceles. So looking at the diagram, I can already see the two sides that are not parallel. We already identified them. They're TR and AP. I want to show that they're equal. So we're going to do the distance of TR. Now, this is a vertical line. We can just count it right on the graph and mark it down there. Okay. So this is just 5. You can count it. So the distance of TR is 5. We want to state it though. And then the distance of the other side we're looking for is AP. I'm going to go ahead and use the distance formula. So square root x2 starting with p is 12 minus x1, which is 9 squared, plus the y's 4 minus 8 squared. This turns into 3 squared plus negative 4 squared, which is the square root of 25, which turns into 5. So they are the same. So TR is congruent to AP. Distances are equal. Okay. And then we're going to go ahead and make our statement. So trap is an isosceles trapezoid since the non-parallel sides, also known as the legs, are congruent. And how do we know that? Because the distances are equal. All right, guys, that is it for today. Have yourselves a great Thursday. Going to be a quiz tomorrow on Schoology. All right, and have a great weekend.